Okay, look, I take exactly the same approach. I look at the limit box, it says x approaching infinity. I say nope. It's factor and divide. I go back to what Christine noticed. I can't factor an h from the numerator, so there will never be any way to do any division, since the only thing in the denominator is h. So I try left-right limits, which means I just say, well, if h gets close to 0, what's that formula going to give me? Well, the top, raise your hand please. If h is very close to 0, what value is the top going to produce? Hands up. Not as hard as you think, just think it. Not hard, Maddie.
0?
Close to 0. Because remember, this won't be exactly 0, so this won't be exactly e squared, but really, really close. How many knew it? 2 points. 3 for Maddie. Don't overthink it. What's going to happen to the denominator when h gets close to 0? Hands up. Listen.
0.
Close to 0. Yeah, it's important to distinguish between 0 versus close. So you're going to end up with close to 0 divided by close to 0. You look at the golden notes, it says, 2 for Melissa, right here. We tried the left and right limits. We ended up with this. Our limit ended up equaling 0 over 0. So we've got to use the Hospital rule. Okay? I believe that is his name in French, actually, the Hospital. Questions? So his rule is really simple. Oh, please, Zach.
The second part, the infinity, positive, negativity, is that just saying if it equals 0 over 0 or?
Yeah, so La Hopital's rule works either way.
Okay.
Now, I don't recall us ever encountering this situation for our class, because the method I teach you here usually supersedes that.
Okay.
Like, if x is approaching infinity, I'm able to solve it using method 1 here. But L'Hopital's rule does work if you get infinity over infinity. So the rule is very simple. It says, instead of doing this limit, create a new limit. So now I'm going to create a new limit problem. Questions? Please.
So is it not just A because even though they're both close to 0, they could get different amounts close to 0?
Yeah, 2 for Kayla. Everyone answer this. Raise your hand if you would say that is close to 0. Raise your hand. Point. Count the zeros. You raise your hand. Which is closer to 0, the top or the bottom? Raise your hand. Which is closer to 0, the top or the bottom? Ashley.
Bottom.
How many agree? Point. Raise your hand if you know what that fraction's equal to. They're both close to 0. Top and the bottom are both close to 0. But what's the fraction equal to? We know. Just count the zeros. There we go. Ella.
Is it 100?
It's 100. So the problem is, when we say close to 0 divided by close to 0, we don't really know. Does that answer your question? Very good. 2 for Ella.
In a problem like this, would h be considered a constant because it's u representing quantity, or is it
2 points for Christine. In a limit problem, whatever the limit shows something approaching, definitely a variable. It's saying h is going to change, it's going to get really, really close to 0. There you go. Okay, we need to create a new limit problem. These are both, like, the key thing is what Christine said. H is the variable. So we have to take d over dh of the numerator. D over dh of the numerator. This is a constant. The derivative of a constant term is 0. The derivative of e to the something is e to that something multiplied by the derivative of that something. Okay, look, here's a place where you've got to not get on autopilot. You have to be thinking. That's got to be DH, because H is our variable in this problem. Question. Cool. So that's simply e to the 2 plus h. Raise your hand if you can tell me what will the derivative of the bottom be. Hands up. What's going to be the derivative of the bottom? Hands. What is the derivative of the denominator? Right here. What is the derivative? Jacob? 1. Because it's going to be dh over dh. How many knew it? Point 2 for Jacob. So our new limit problem looks like this. We're now finding the limit as h approaches 0 of e to the 2 plus h divided by 1. We take the exact same steps. We look to see if h is approaching infinity. It is not. We cannot factor in and divide. We can, however, remember what limit means. Limit means if h is close to 0, what is the blue box going to give us? Hands up. If h is close to 0, what do we get in the blue box? Curtis?
E squared.
End of story. Collect my points, move on. What do you got it? Point 2 for Curtis. Please. Questions here? Please, Luke.
So when we're finding the derivative of the bottom, we just consider it just the h, not 1 over h?
Oh, thank you. 2 points for that. Yeah, L'Hopital's rule. Look at your golden notes. No, really good question, Luke. Right here is the answer to your question. L'Hopital's rule says if this occurs here in green, if what you see here in green occurs, you try to find the limit, and you end up with a 0 over 0 limit. He says create a new limit problem. The new limit problem is simply the derivative of the top alone divided by the derivative of the bottom alone.
Okay.
So you treat them completely separately. Does that answer your question? 2 more. Please, miss.
Where did the minus e squared go?
Hold on. 2 points. I think I can get you to see it for yourself, then you'll remember better. Is that okay? So we're trying to find the derivative of this. With me? E is about 2.7. So 2.7 squared, close to 9. Make sense?
Yeah.
It's minus a constant. What's the derivative of any constant term along? Just 0.
Okay.
Does that answer your question?
Yeah.
Good one. 2 more. Please, Cameron.
So one thing I forget, like, so let's say that it was e squared multiplied by e squared plus h, e squared plus h. Like, what would be the derivative of that? I always forget that.
So you're saying if we're doing the derivative of, say it again,
E squared multiplied by e squared plus h.
did you mean like e to the 2 plus 8?
Yeah, sorry, yeah.
Like that?
Yeah.
So then what I would do is this is a multiplying constant. So it just tags along.
Oh, okay.
And then the derivative of this is itself. So that's the derivative.
Oh, okay.
2 points.
Couldn't you like add them together so because they're being multiplied you could use
Uh-huh. So the properties of exponents would allow you to rewrite this like so. Not required on an FRQ, but you can. 2 points. Savannah, which one?
12.
12.